So how do we initialize an array? The values are written with curly brackets, such as this one, and every value separated by commas over here. So this is one of an example where it is an integer with the name mark with an array size of 5. Inside here, it is already declared inside the memory here, where the mark 0 is equal to 19, mark 1 is equal to 10, mark 2 is equal to 8, mark 3 is equal to 17, and mark 4 is equal to 9. Okay, there is the example down here. Oh, I've already talked about it. So here it is. Here, how it should be outputted if you print the said names for each of the memories. So while initializing the array, so at the time of declaration, the programmers may omit to mention the size of an array. For example, integer mark blank equal to 98, 97, and 90. So will the compiler get an error or not? So the statement just now is completely legal, hence the compiler will allocate enough space for all initialized elements. If the number of value provided is less than the number of elements in the array, the unsigned elements are filled with zeros, such as this. If you set the size is at 5 and then you put 90 and 45 inside here, the rest will be filled by the compiler with 0. Okay. So in C, if array has a size of n, we can store up to n numbers of element in the array. However, what will happen if we store less than a number? So yeah, like I mentioned just now, it will be filled with 0. So array did not have any value. We have to store value in an array. So we initialize as follows: integer num equal to 6, 2, 4, 12, 5, 45, and 5. And the rest is integer n blank equal to 2, 4, 12, 5, 45, and 5. And float press equal to 12.3, 34.2, negative 23.4, 11.3. There should be a comma over here. So there are a few methods of how to initialize an array, such as method 1, ARR size 5 equal to brackets, and you fill in the 5 spaces inside with a number. Or you can also write ARR without any size, and you put any number, any amount of memory inside here, and technically you can see this as a free size declaration or initialization. So with the method 3, this is not a preferred method where you declare each of the spaces inside here with a value manually one by one. This is too slow and too long for a code. It works, but it takes too long to write. Better just write it like this, the first method. And the fourth method, ARR5, and it uses a for loop to input your own data automatically outside the coding itself. So when this is run on a compiler, and you have to input your data one by one by just typing inside, because there is a scanf coding over here. Okay, let us see an example of one-dimensional array. So if you write this code, it will come out with this output where the third element is 2000. The array with the new third element 1, 2, 3, 2005. So over here, if we read the coding one by one, so this is standard lah. This is standard input output with the int main as your big coding, your big body of a code, and you initialize integer I and then integer mark 5 is equal to 1, 2, 3, 4, 5 inside the memory. Then you declare over here mark the third place without any integer. This is not a declaration, it is just a this you insert the value inside the element of the array. So when you change the value, you just write it as mark bracket 3, which indicates the fourth place, equal to 2000. So here it just prints f, the third element, percentage d slash n mark 3. So it just grabs the value from here, and then print f, the array with the new third element slash n goes to the next spacing, and it uses a for loop to print f each of the memory inside here. Like I've mentioned just now, mark 3, it is the fourth place because the initialization of an array starts with 0 and then goes to 1, 2, and 3. So it replaces the number 4 over here with 2000. So to see how for loop works in this code, here we already initialize integer I over here, and I is equal to 0. Since I is less than 5, it adds the value I to 1, and then it prints over here, printf, percentage %d, mark I. Since the I is already with this declaration, I++, it will delay the increment, and the mark over here is still declared as 0. So it will print the value for mark 0, which is number 1. And since I is still less than 5, it loops back above here, and I is equal to 1. 1 is still less than 5, increment the value, mark 1, checks number 2 over here, checks 2, still less than 5, repeat, 2 is I is equal to 2, 2 is less than 5, increment, and it will see the third value, and so on, looping until I is equal to 5 and ends the coding. So this is the output. The third element 2000, the array with the new third element 1, 2, 3, 2005.